Hi, this is Victor and Jeffrey, and we're back again for tutorial number 2 of the Erebus competition in Webots. So in this video, we will cover the basics of coding in Webots. By the end, you should be able to make a robot move around within Erebus, as well as learn how to use the motors, motor encoders, and gyro sensor of the virtual robot. So note that the main portion of this video is in C++, and we're going to be coding it in C++. But by the end, we'll also provide Python equivalents to the C++ syntax we use. So even if you are using Python, however, you should still watch the C++ portion because the basic syntax of Python is pretty similar to C++, and you shouldn't have that much of a problem understanding the C++ explanations. Also, the Python section will not cover the concepts that are covered in the C++ portion, which are needed for like the Erebus competition. So the Python section contains syntax and syntax only. So for these first few tutorials, we will be using the built-in Webots text editor. If you want to use your own IDE like Visual Studio, that's fine. Webots has instructions on their tutorials page on how to configure your IDE environment, and we'll try to link that in the description. For now, it's easier to just stick with the default recommended text editor of Webots, which is what we are going to use. We're going to start by creating our first C++ controller. So let's open up Webots' text editor by going to Tools and then Text Editor. And this panel right here will pop up. So let's create a new file and we're going to save as this file. But before we save it, one thing you should note is that within this controllers directory, all your C++ controllers should go within here. So you can see Robot 0 controller and Robot 1 controller. We're gonna make a new folder to store our controller. And for like C or C++ controllers, each separate controller should go in its own folder within the world's controllers directory. If you don't put your C++ controller within a folder in the controller directory, then Webots actually won't recognize your files as a valid controller. So let's create a new folder. And let's call it my controller. And then let's save our file as main.cpp within my controller. So before we get into using like the motors, encoders, and all the sensors of the virtual robot, we're going to begin just by creating a basic Hello World program. So in Webots, a controller is really just any kind of program, and Webots executes controllers as separate processes when running the actual simulation. So it's perfectly fine for us to write a controller that doesn't do anything besides print Hello World. And these print statements are actually going to be redirected to the console down here, and you'll see that once we run the program. All right, so to write a simple Hello World program, we're going to start with our include statement and using namespace std, have our int main, as well as just a simple cout statement. And a return 0. So all this program will do is print hello world, and that's it. So now that we've finished writing our code, we need to build the controller. So to build our controller, we just need to press this button for building, which is a gear right here. And Webots is going to ask us if we want to create a makefile, so just hit OK. So for building and compiling programs, Webots uses something called Make, which is a tool that automates the process for building. And Make gets its instructions from something called a Makefile, which tells Make how they want the program to be built and with what parameters. All we have to do is adjust our Makefile according to our needs, and Make and Webots will take care of the rest. So let's open up our Makefile and take a look at what's inside. So this is the Makefile that was automatically created by Webots since we didn't have one that we created ourselves. And the bottom lines of the Makefile right here, these should not be modified, and it's telling you don't modify it. Instead, all we have to tell the Makefile is we have to direct it to our C++ source file that we just created called main.cpp. And in order to do that, you can see that it gives you instructions right here. All you have to do is type cxx sources equals main.cpp. And that's going to tell the Makefile that you're looking to build main.cpp. If we had multiple source files, like if we had foo.cpp, all we would have to do is have a space right after this and say foo.cpp. And since we only have one file, we're going to leave it as main.cpp for right now and save that. All right, so now we're going to attach the controller we just built to one of the robots. So I'm going to zoom in on this robot right here, and if we click on it, it's going to be highlighted, and this is actually robot 1. So let's expand this, and we're not going to use the Erebus custom UI in order to load this controller into this robot. Currently, the Erebus load controller button supports Python scripts. Since we just wrote a C++ controller, we instead are going to attach the controller manually directly into the robot. If your code, however, is in Python, feel free to use the Erebus load controller feature right here. All right, so let's attach the controller, and to do that, we click on controller right here, and we're just going to select another controller. And here's just a list of controllers that Webots has found that you can attach. And if you'll notice, the controller we just created called My Controller is right here. So let's just attach that and press OK. And now the controller is attached to the Pioneer 3DX for Robot 1. Now let's just run the program. Pause it. And you'll notice that My Controller printed Hello World.
So as a quick recap of what Victor said before, those of you who are using C++ should have created a controller inside the Webots text editor and saved it in the folder Erebus Aura, Game, Controllers, and inside this folder. That way, when you go to link it up with this robot using the scene tree over here, it will show up as one of the options. Now, Victor was using the Webots text editor over here. Since this window is a little bit small, I'm going to be using a program called VS Code, Visual Studio Code. Now, you can use any text editor you want, like Notepad++ or Visual Studio, but you have to remember that you need to save your code inside your text editor. Then you need to build and run your code inside of Webots. That way, all your code will build and link properly. Before, Victor created a controller using this text editor. You can also use Wizard's new robot controller and follow these steps over here. Now, if you use the wizard to create a .cpp robot controller, the program that will come up for you looks a little bit like this. So these are all the basic lines to a standard C++ robot controller. There are also a lot of comments, but I've removed them just so you can see the code a little bit better. That doesn't mean that the comments aren't important. You should definitely read the comments when you create your robot controller. So now let's go over the basic lines of code that you will need for any C++ robot controller. So up here we have our pound include. This basically grabs some functions from robot.hpp that we will need to run the robot around. And this does something similar, except it's for Webots functions and objects in general. One thing to keep in mind is I've included a robot.hpp so I can use functions related to the robot itself. If I need any new devices such as a motor or a sensor, I will have to add a #include for each new device that I use. We'll show you how to do this a little bit later. So now, let's get into the main. This right here creates a object called r robot using the class r robot. Now, for those of you who are unfamiliar with object-oriented programming, don't worry about this for now. All you have to know is you can think of this robot almost as a variable. In reality, we call it an object. So the robot is an object. We can use the robot object to call functions such as you can see right here. So I use the robot object and this arrow to call this function right here. That is why you need the robot object. And same thing with the #includes over here. Every time you want to use a new device, like a motor or a sensor, you will need to create a new object for that device. And then you can call the functions related to that device. Now, timestep is a variable, and it represents the time between each iteration of this while loop right here. So basically, how Webots works is it takes this main while loop and it runs this continuously over and over and over again until you stop the simulation. The time between loops is timestep. So for example, let's say this function right here, getBasicTimestep, returned 32, and therefore timestep would be equal to 32. That means in between each iteration of this loop, there will be 32 milliseconds of time. So let's say I have some code in here. This code will be executed every 32 milliseconds. So let's say I declare int x equals 0. And over here, I do x equals x plus 1. Since my time step is 32, that's an example. If you want to see the actual value, you can always print out time step, and you can see the true value for yourself. But let's pretend that time step is 32 milliseconds. That means this code would get run every 32 milliseconds. So x would get incremented every 32 milliseconds. This delete robot line just basically cleans up this robot object. And then that's it for the basic lines you need to every C++ robot controller for Webots. Now, Webots runs this file just like any other application would. It just runs main and it goes straight down through the code. So these lines of code get looped once, as they normally would, and this while loop gets run over and over and over again, going back to the time step. Remember that if time step was 32 milliseconds, all the code inside of here would get looped continuously every 32 milliseconds. Let me show you what I mean. So let's say, since this code only gets run once because it's not inside of this loop, I'm going to put a print statement. I'm going to say runs once. Now, when you do print statements, you have to make sure that you put a \n, or else it will not show up when you run the simulation. So do a printf in here, and since this is inside of the loop, I'm going to put runs many times \n so that it shows up inside the console inside of Webots. So now, what this program should do is it should print out runs once, and then print out run many times. So remember, make sure that it's saved inside your text editor. Build it over here. Now, as you can see, I saved it inside my VS Code text editor, and it automatically updated inside of here. You can see my print statements right over here. Now I can reload my world. And remember, this scene tree, since I saved my world, this controller is always going to be linked to my controller, and I can just hit play. Now, as you can see, I'm going to pause the simulation. It goes up. If I scroll up, it prints out runs once, and then runs many times, because it was inside this loop over here. And if time step was equal to 32, it would print out runs many times every 32 milliseconds. So now you have an okay idea of how the Webot program structure looks and how to work with it. And it's very important when you keep in mind how to structure your code. You have to remember that it doesn't run just sequentially. This loop loops over and over again very fast. And you have to remember that the code inside of this loop, so this code right here, cannot exceed time step. So if this print statement took more than 32 milliseconds to run, which it won't, then you would encounter problems that could include crashing or freezing. So that especially means you cannot delay your code with delays inside of this while. Any normal function call would work. So that's it to the basics of coding a C++ robot controller.
All right, so we tried the Hello World example and that worked. So let's move on to something more complicated and actually get our robot to start moving. So we're going to edit directly in this main.cpp and make a couple of changes. For one thing, we're going to actually create a robot object by first including Webots slash robot.hpp, and we also have to use the namespace Webots. And down here inside of main, actually not inside of main just yet, but we're going to do robot equals new robot. So this creates a new robot object, and right now we also have to create the left and the right motors in order to actuate the motors to get the robot to move. So we're also going to use the correct include by doing #include webots slash motor.hpp. And this particular robot, the Pioneer 3DX, has a left and a right motor. So we're going to need two motors. And we're going to do motor, left motor equals robot get motor, and then the name of the motor. So the name of the left and the right motor is left wheel and right wheel respectively. So let's create two motors. Robot get motor right wheel. And there we go. So notice how these motors are coming from the robot object we just created. Now down here, how Webots functions for motor control is that Webots actually lets you do a couple things. It allows you to set the position of the motors in order to reach a desired position, or you also have velocity control where you control the velocity of motors, and you actually can do some control with acceleration as well, but we're not going to get into that. For right now, we're only going to use velocity control, which means that we don't set a position, but we do set a desired velocity. So to set a velocity for the left and right motor, we're going to do left motor set velocity, and let's set it to let's just set it to 1, and same thing for right motor. So as Jeffrey explained, everything in Webots must go inside of a basic time step loop. So we're going to get our time step by doing int time step equals robot get basic time step. So depending on what your world time step is set to, this will get the correct time step so you can use it. And while this is going to be our main loop, step time step does not equal -1. And now we have written our main body loop, and this is going to get periodically called throughout the simulation. So Remember, you can't have any delays within your program because that's going to delay the calling of this loop, this key loop right here. All right. So we've set our left and right motors to move at a speed of 1. There's one more thing we have to do though. In order to actually activate the velocity control, we should set the positions of the left and right motors to infinity. So to do that, all you have to do is left motor set position to infinity, and same thing. Right motor set position to infinity as such. All right, and assuming I didn't do anything wrong, this should work. So let's try building it. So it built and it was successful. So let's reset the world and let's run the world and see what the robot does. And there you go. It moves forward.
So for those of you using Python, things are going to work a little bit differently. Firstly, to create a Python controller, let's create a new file inside the Webots text editor, and then we're going to do a save as, and then for C++, we saved our controller inside of Erebus Aura, game, and controllers. That way, when we linked up our code to the robot, it would show up as an option because we were using the scene tree. However, for Python, we're not going to use the scene tree, and instead, we're going to save it inside Erebus Aura player controllers. And I'm going to call it my controller. And we're going to do a .py extension so that it recognizes it as a Python script. And then we're going to hit save. Now, one thing to make note of is, for C++, we changed this field inside of the scene tree so that it links up with this controller that I'm programming. However, if you're using Python, you do not want this to be linked up with the code that you're writing. You want this to be linked up with the Robot 1 controller, or Robot 0 controller if you're using the other robot way over here. That way, when you load in a controller, it will run the controller that you load in successfully. So, I'm going to hop back into VS Code. Remember, you can use any text editor you want as long as you save it and you load it properly. So let's go here and open up my controller. So I'm going to copy in the basic lines of code that you need for any Python script. And just like we did with the C++ robot controller, we're going to go through it line by line. So this from controller import robot acts similarly to the pound include robot.hpp we saw in the C++ code. It basically grabs any methods associated with robot that we'll need for running the code. Now, this, just like in the C++ code, creates a robot object. In this case, we call it myRobot. Once again, you can think of myRobot as an object that represents this robot right over here. So, now time step in Python, we actually define ourselves. So we're going to define it to be 32. That means this while loop will iterate every 32 milliseconds. So the code inside of here will run every 32 milliseconds. So just like we did with the C++ code, let's put some print statements in. So once again, printing inside of Webots is the same for any old Python program. I'm just going to do a print. I'm going to print out runs once. And then I'm going to put inside this while loop, print runs many times. And since Python just runs the code from top to bottom, it's going to start here, does this, that's all fine. And it's going to print out this once because there's nothing looping it. Then it hops to this while loop. Then it prints this out in rapid succession. And it prints it out once every 32 milliseconds because my time step is defined as 32 milliseconds. So now, to load in my Python controller, it's relatively simple. I just make sure I save it inside of here. I'm going to hop back to Webots. I hit load controller under robot 1. And remember, I saved my code under the player controllers folder because I'm using Python. If you don't save in here and you save it in the folder we were talking about before for the C++, your code is going to get wiped when you load it into the controller. So it's very important that you go into player controllers, and then I'm going to select my controller. So as you can see, this box turned red, and that means I know that my code is linked to this robot. So I'm going to run my code. And just like before, I'm going to pause the simulation, scroll up, and you can see that it printed out runs once because that code was outside of the loop, and it prints out runs many times because that code was inside the loop. Specifically, it prints this out once every 32 milliseconds. So this is the basic controller outline for any Python script. So with C++, you saw that you had to do a few things to get your motors to run. First off, you had to do a #include motor.hpp. Secondly, you had to create a left motor and right motor object so you could run motor functions on either of the motors on the robot. Next, you could do a set position and set velocity on the motors. And Python has equivalents for all of these. Firstly, you have to do a from controller import motor to grab all the motor functions that you need. Next, to create left motor and right motor objects, you just do left motor, then call myRobot.getMotor, because getMotor is a function associated with the myRobot object, and then you specify the left wheel for left motor. And you do the same thing except for the right motor. Now you have a left motor and right motor object just like you did with C++. Now to set position, all you have to do is left motor dot set position, and if you want it to move infinitely, all you have to do is float and then infinity inside quotation marks. And you can do that the same for the right motor. And set position for Python works the exact way for set position in C++. This is the target amount of radians that you want your robot to travel. Next, set velocity just sets the speed that you want both motors to run at. And those are the Python equivalents for all the C++ functions to run the motors. So let's load this into controller and see what happens. Let's go load controller, toss in my controller, and then hit play. Now as you can see, the robot moves forward at a velocity of 4. Remember that the max moving speed is 10, so this is, say, a 40% power level, and it moves forward infinitely. So that is the basic motor movements for Python. So this was a tutorial on the basics of coding in Webots. Now you should know the basic syntax for motor movement and gyro from the Simba code that Victor and I gave to you earlier in this video. If you're confused on any of this, there will be another webinar, another Q&A session on the 27th, May 27th at 6 p.m. Eastern Standard Time. So be sure to go there and check that out. In addition to questions, we will go over the material once again, so it's always worth checking out. So thank you for watching this video and have a good week.